Welcome to EDU World Space.
So here we have to find the Compton wavelength shift for a photon scattered from an electron. So we will use equation 27.7 for this, and according to this equation, lambda dash or the scattered wavelength is equal to the unscattered wavelength or initial wavelength plus h over MEC times 1 minus cos theta. And theta is different for each of the parts of the question. Theta is the only parameter that's different. So lambda dash minus lambda is the shift, the wavelength shift. This is equal to h over MEC times 1 minus cos theta. Now this factor, as you can see here, the boxed one, is called as the Compton wavelength. And this is a constant, so let's find lambda c to make our calculations easier in the later part. So lambda c is h over MEC, and h is Planck constant over mass of the electron times the speed of light. And solving this, we get lambda c to be 2.43 times minus 12 meter, or 2.43 times 10 to the power minus 3 nanometer. Now let's do part A first. So for part A, theta is given to be 45 degree. So we will use this equation now. Taking the value of lambda c to be what we found here. So lambda dash minus lambda is lambda c 1 minus cos of 45 degree here. So this gives lambda dash minus lambda to be 2.43 times 10 to the power minus 3 nanometer, 1 minus cos of 45 degree. And this gives the value 7.12 times 10 to the power minus 4 nanometer. Yeah, so let's mark this as lambda dash A for the first part. Now notice that the question is asking about the Compton wavelength shift. So basically this is the value that the question is asking for. So we don't need to use the value of lambda or the initial wavelength at all in this equation. So this might be a little confusing for you, but yeah, you don't need to use that in this question. So let's move for part B now. So for part B, theta is 90 degree. So lambda dash minus lambda, I'll say this as lambda dash B, is equal to lambda c 1 minus cos of 90 degree. That is equal to lambda c is 2.43 times 10 to the power minus 3 nanometer. And cosine of 90 is basically 0, so 1 minus 0 is just 1. So this is the Compton wavelength shift for part B now. Now for part C, theta is equal to 180 degree. So the Compton shift for part C will be, Compton wavelength shift for part C will be lambda c times 1 minus cosine of 180 degree, which is equal to 2.43 times 10 to the power 3 nanometer. Cosine 180 is minus 1, so this factor will basically be 2 here. And so it's equal to 4.86. So yeah,